Assalamu alaikum students. In the previous video we have studied the radial and transverse component of velocity. In this video we will study the derivation of radial and transverse component of acceleration. So let's start where we left with. So the velocity is equal to dr by dt and r unit vector plus r dot d theta by dt into s unit vector. As we know that acceleration is equal to change of velocity with respect to time, so we can take the derivative with respect to time of this whole term plus r dot d theta by dt as unit vector. Now these are two terms, so first take the derivative of first term and let the second as it is, then let the first as it is and take the derivative of second one. Similarly हम ये second term ले लेते हैं which is dt by derivative of first term which is dr by dt and remaining as it is, then derivative of the second term first as it is and d by dt into d theta by dt and s as it is, then r and d theta by dt as it is and derivative of ds by dt. So we can write this as d square r over dt square into r plus हमने last video में देखा कि we can write dr by dt as d theta by dt into s unit vector. So we can write this as dr by dt and this term can be written as d theta by dt into s unit vector plus dr by dt d theta by dt into s unit vector plus r dot, this can be written as d square theta over d square dt square as unit vector plus r dot d theta by dt, और लास्ट वीडियो में हमने ये भी देखा कि ds by dt को we can write minus d theta by dt or minus d theta by dt into r unit vector. So we can write as minus d theta by dt into r unit vector. So the above term can be written as d square r over dt square into r unit vector plus these two terms are same, so we can add them, dr by dt into d theta by dt into s, and by adding we can write the 2 plus r dot d square theta over dt square s minus d square theta over dt square r into r unit vector. Now it can be done as d square r over dt square. We can write this last term here, it is d square theta over dt square r into r unit vector, then this term here 2 dr by dt d theta by dt into s unit vector plus r into d square theta over dt square s unit vector. So by taking the r unit vector common, we can write as d square r over dt square minus r into d square theta over dt square plus By taking the s unit vector common, we can write as dr by dt into d theta by dt plus d square theta over dt square s vector, s unit vector. So we have the radial and transverse component of acceleration, which means A is the radial component, radial component of acceleration, which is d square r over dt square minus r d square theta over dt square. Similarly, the transverse component is two r by dt d theta by dt plus d square theta by dt square. So these two are the radial and transverse component of acceleration. Thank you very much.